Parallel computing systems have a crucial role in many applications, such as simulation sciences that require a massive amount of computations. These systems are extremely complicated due to the amount of compute nodes or the interactions between the system and its users. It is crucial for administrators to monitor the system's operations because they need to quickly recognize dangerous failures happening to the system, such as burnout or harmful activities, so they can have appropriate solutions. Along with the computer's strength in automatical monitoring, visualization also combines human recognition abilities into the monitoring process. The visualization helps administrators gain insights into the system through visual representations and interactions, so they can understand the system's situations before making any decisions. It is the reason why we propose an application of visualization techniques to monitor an HPC system. The main visualization bases on the idea of a graph in which each node or user is a vertex. When a user utilizes a node, there is an edge between them. Our prototype is applied for a cluster of 467 nodes in an HPC system at a university. However, the graph-based design can open up the scale of the visualization for clusters whose size may be up to thousands of nodes. The interface has three main components. The main view in the center that visualizes the whole HPC system. The control panel on the right side provides features such as sorting, visualizing, and the legend of health metrics. The timeline on the top is able to control by dragging and clicking to jumping into a specific time point in the main view. Users are placed in the middle of the surrounding nodes, which are grouped into 10 racks. A node has two visual signs that carry useful information for the administrators: its outline thickness and its color. The more jobs a node is running, the thicker outline it has. The outline thick can give an overview of information about job scheduling. For example, we observed that some nodes may be assigned more than one job, while there are some unused nodes in the system at the same time. There are 9 health metrics of a node in the system: 2 CPU temperatures, inlet temperature, 4 fan speed, memory usage, and power consumption. We can use Sort button to sorting nodes by current visualizing metric. It is noticeable that 4 nodes have extremely high fan speed in rack number 4. These nodes have IP numbers related together and running by different users. Indeed, these nodes have been allocating in the same chassis. CPU2 temperature of node 10.101.4.33 started increasing to reach its peak at 11:35. At 11:35, we can see that 4 fan speed of the 4 nodes also grows, before reaching the peak at 11:40. Usually, the CPU2 temperature will be lower than the CPU1 temperature due to the cooling arrangement of a node. However, node 10.101.4.33 has a high CPU2 temperature. When CPU2 temperature drops at 11:45, the 4 fan speed of the 4 nodes also reduce. At this point, we want to see all the metrics at the same time. On the visualizing selection, choose Radar. This option displays each node by a radar chart that shows all 9 metrics of the corresponding node. Moreover, the nodes are classified based on their metrics by one of 2 classification algorithms, k-means and leader bin. It turns out that 3 other nodes 4.34, 4.35, 4.36 has low CPU1 and CPU2 temperature, but the fan speeds are very high. The reason is those 3 nodes have been heated up due to node the overheating event in node 4.33. The correlation between CPU2 temperature of node 10.101.4.33 and 4 fan speed of the 4 nodes implies that these nodes stand near each other, so sensors in the fans can feel the temperature from node 10.101.4.33. After report this discovery to the server management. We found out the reason behind this overheat event on node 4.33 is the bad implementation when replacing CPU2 on that node. One of the important question the administrator want to know is how efficiency is the job scheduling allocates the job. If we choose User in the Visualizing tab, each node is colored similarly to all of its users. The node may have only one color or many colors. In case the node isn't running any job, its color is white. Mouse over user or node to highlight the related connection between them. It is clean to see one user can utilize many nodes and a node could be run by one or more users. The question is, why some of the compute in white not been assigned for any job? The node 10.101.2.15 has been in idle status from the beginning of August 14 to August 18. It has turned out that the job scheduling want to reserve this node for a big job from user Lydia's and later on is Q25856.